Hey everyone, ready for some serious mountain talk? We're diving into the mighty Mount Everest today.
Yeah, it's the tallest, the most iconic. But have you ever thought about what makes it tick? Like, what's going on beneath all that rock and ice? And how high can this thing actually grow? We're going to get into all that. We're digging into some cool research about the forces shaping Everest. It's a total tug of war. You've got plate tectonics pushing it up, and then erosion doing its best to wear it down. Trust me, when you're talking Everest, it's way more than just a mountain.
Yeah, it's a wild balancing act, really, and it reminds you that even something as permanent as a mountain, yet it's always changing. Right. Okay, so before we get too far ahead, let's rewind a bit. Picture this. It's 1852. This mathematician, Radhanath Sikdar, he's working with the British Great Trigonometric Survey, trying to map the Himalayas. Can you imagine? Using trigonometry to figure out how tall Everest is.
No way! Back then, no satellites, no lasers. It's amazing, really. His measurement was only off by like 30 feet compared to what we know now.
30 feet, that's insane for the 1800s. But, okay, that kind of makes you wonder, even today, how do you measure something like Everest? Where's the starting point?
Oh, it's way more complex than you'd think. Like, is it sea level? But what about the mountain's base? That's buried under tons of stuff. Even the summit. Do you include the snow? Because that changes all the time.
Ah, okay. So that's why in 2020, China and Nepal, they had to team up, right, to figure out Everest's official height.
Exactly. They had different methods. Even argued about the snow cap. Shows how even measuring a mountain, it's all about perspective, how we decide what things are.
And speaking of perspective, didn't I read somewhere that there's another mountain, one that's actually taller than Everest?
You're thinking of Chimborazo
Hmm.
in Ecuador. Here's the thing. If you measure from the Earth's core, Chimborazo wins by a lot. Over 10,920 meters.
Wait, what? So Everest isn't the tallest after all? My mind is blown. How did that even work?
The Earth, it's not a perfect sphere. It bulges at the equator. So Chimborazo, it's closer to the equator than Everest, meaning it's actually farther from the Earth's core, even though it's shorter from sea level.
Okay, that is just cool. So it's not just about height, it's about the planet's shape, gravity, all of it.
Mhm.
But back to Everest. How did it get so huge in the first place? It's not like
Well,
someone just stacked rocks, right?
Huh, no. We're talking millions of years in the making. It all starts with Pangaea. Remember that. The supercontinent. Think continents drifting, smashing into each other. A very slow-motion cosmic dance-off.
I bet that was an intense dance-off. How does that create Mount Everest?
Well, the Indian subcontinent, that was the main player here. Moving north, slamming into Asia, about 45 million years ago.
That had to be explosive.
Understatement. That pressure from that collision, that's what made the Himalayas, Everest included.
So Everest is like a giant wrinkle from that crash.
Exactly. And get this, the Indian plate, it's still moving super slowly, like 5 centimeters a year, still pushing on the Eurasian plate. That's why Everest is still growing. Although now it's more like, what, 4 millimeters a year?
Everest is on the move. Who knew? But if it's always growing, why is it even taller?
Yeah.
That's where erosion comes in, yeah. So it's like a mountain is constantly battling, right? Growth versus erosion. What are the biggest things wearing Everest down?
Well, you've got the classic trio, wind, rain, ice. They seem kind of small, but over time, huge impact.
Right, millions of years. You don't notice day to day.
Exactly. Glaciers are like, imagine rivers, but made of ice, carving through the rock.
Like sandpaper on wood, kind of. But way bigger scale, obviously.
Exactly. Then you've got rivers, actual water this time, cutting through.
Yeah.
And even the wind, it picks up tiny particles. Those wear away at the mountain, too.
I read about this weather station on Everest. Got messed up by flying rocks, like cricket ball size, they said.
Yeah, that's no joke.
Yeah.
Shows you the power of those forces. It makes you think about those climbers, huh?
Out in that. So we've got this push and pull, uplift, erosion. But does erosion ever, I don't know, H-E-L-P, a mountain grow?
Now, that's an interesting thought. There's a theory, right? Erosion takes way off the top, so maybe, just maybe, that lets the tectonic plates push it up even more.
So less weight, more height. Like if you take off a heavy backpack, you stand a little taller.
That's the idea. But it's tricky. Lots of forces at play. We don't totally get how it works on that scale.
This stuff is wild.
Mhm.
Millions of years. Makes you feel kind of small, you know? But we've been earthbound this whole time. What about mountains on other planets?
Oh, now you're talking. Olympus Mons on Mars. That's a whole other
How
level.
big are we talking?
Everest is about 5.5 miles tall, yeah. Olympus Mons. Try 13-mile high.
Get out. Seriously.
No joke. Imagine something the size of Arizona. That's how big this thing is.
Okay. That's just not fair. Why is Mars so good at making mountains?
Couple reasons. One, gravity's way weaker there. So mountains can get taller before they, like, crush themselves.
Makes sense. Less gravity, bigger mountains. What's the other reason?
Plate tectonics. Earth's got 'em, Mars doesn't. Not really. Here, plates move, mountains get made and destroyed, limits them. But Mars, a volcano like Olympus Mons, it could just sit over a hot spot for, like, billions of years, getting bigger and bigger.
So Earth, we're more active,
Yeah.
restless. Our mountains are cool, but maybe not Mars level cool.
Pretty much. Different planets, different rules. It's pretty amazing.
Makes you wonder, could Everest ever go supersize given enough time?
Yeah.
Become Earth's Olympus Mons?
Probably not. Even if the Indian plate kept pushing, Earth's mantle, deep down, it'll cool off eventually. Plate tectonics would slow down, maybe even stop. No more pushing means no more growth for Everest.
And then there's erosion, always working against it.
Right, like you said, a constant battle. And over enough time, erosion's gonna win.
So even giants have their limits. Speaking of which, did you know Everest might not even be the fastest growing anymore?
Oh yeah. Nanga Parbat, over in Pakistan. It's giving Everest a run for its money.
How fast are we talking?
It's about 8,126 meters now, but some think it's growing almost twice as fast as Everest, maybe 7 millimeters a year.
Wow, that's moving. Will it be the new champ in a few million years then?
Maybe, but it's not just about speed. Erosion matters too, and that's almost impossible to predict long term. Even a tiny change in climate, how the plates are moving, could throw things off.
Right. Trying to predict mountains is like predicting the weather millions of years out. Speaking of which, we've been in our science zone for a while, but Everest, it's more than just rocks and numbers, right? It means something to us, to people. We'll get into that right after this. And we're back. Last leg of our Everest journey. We've covered so much, like the science behind it, how we even measure it. But here's the thing. There's something about mountains, Everest especially. It's not just about the science. It just grabs people.
Totally. For a long time, mountains have been these, like, majestic, almost mythical places. They're a challenge, right? A test. You go up against something bigger than yourself.
It's like that saying, you conquer yourself, not the mountain.
Exactly. And Everest, well, it's the tallest, right? So it's the test if you're a climber.
Right. I was reading this interview with Billy Bierling. She climbed to Everest back in '09. She said, and this stuck with me, the exact measurement doesn't matter. What matters is it's the highest.
Yeah.
And that you go to the highest point just hits different,
It's not about the numbers. It's about what it means. The challenge, the journey, to be up there on top of the world.
And in this day and age where everything's got to be precise, data, it's kind of cool to hear that. The number isn't everything.
Sometimes the most important stuff, you can't even measure it.
Totally. Well, we're about to descend from our Everest of knowledge here, but one last thought for you all to take with you. Imagine you're valet measuring Everest. No fancy tech, no super accurate tools, just you. What would you do? How would you measure it so it meant something? That's it for our deep dive today. Huge thanks for joining us all the way to the top of the world. We'll see you next time for another one, folks.